Ever wondered how much fence you need for your garden? How much paint to buy for your walls? Or exactly how much batter will fit in your cake tin? These everyday questions all depend on three fundamental mathematical concepts. A farmer planning to fence his field needs to calculate perimeter, the distance around the boundary. An architect designing a building must calculate area, the amount of space within the floor plan to determine materials and costs. And a baker filling a cake tin needs to understand volume, the three-dimensional space that determines exactly how much batter the container can hold. From painting rooms to filling swimming pools, from designing parks to packaging products, perimeter, area, and volume are the mathematical keys that unlock solutions to countless real-world problems. Now that we understand what perimeter, area, and volume represent, we need to learn the essential formulas that allow us to calculate these measurements for common shapes. These formulas are the foundation of all measurement problems. We'll start with the square, one of the most fundamental shapes in geometry. A square has four equal sides, which makes its formulas particularly elegant and easy to remember. For a square with side length s, the perimeter is simply 4 times the side length. This makes sense because we're adding up all four equal sides that form the boundary. The area of a square is the side length squared. This represents how many unit squares fit inside our shape. If each side is s units long, we can arrange s times s unit squares to fill the entire area. Next, we have the rectangle, which extends the square concept to shapes with different length and width. The rectangle formulas build naturally from our understanding of the square. The perimeter of a rectangle is 2 times the length plus 2 times the width. We have 2 long sides and 2 short sides, so we add them all together. The area is simply length times width. This tells us how many unit squares fit inside the rectangle when we arrange them in rows and columns. Triangles are fundamental three-sided shapes. While calculating perimeter requires adding all 3 sides, the area formula has an elegant relationship to rectangles. The area of a triangle is 1/2 times base times height. This works because a triangle is exactly half of a rectangle with the same base and height. Circles introduce us to the mathematical constant pi. The circle's formulas are some of the most beautiful in mathematics, connecting the radius to both circumference and area. The circumference, which is the perimeter of a circle, equals 2 pi times the radius. This formula captures the fundamental relationship between a circle's size and the distance around it. The area of a circle is pi times the radius squared. This elegant formula shows how the area grows with the square of the radius, making circles very efficient at enclosing space. Now we move into 3 dimensions, where we calculate volume, the amount of space inside a solid object. We'll start with the cube, the 3-dimensional version of a square. The volume of a cube is the side length cubed, or s to the 3rd power. This makes perfect sense. We're filling a 3-dimensional space with unit cubes, arranged in layers of s by s squares, stacked s layers high. Finally, we have the cylinder, which combines our knowledge of circles with 3-dimensional thinking. A cylinder is essentially a circle extended upward through space. The volume of a cylinder is pi times radius squared times height. This formula combines the area of the circular base with the height, showing how we stack circular layers to build the 3-dimensional volume. These essential formulas form the foundation for solving measurement problems. Notice how they all connect to the fundamental properties of their shapes: the number of sides, the dimensions, and the geometric relationships that define each figure. Now we'll apply our understanding of perimeter to solve a practical problem. A gardener wants to fence a rectangular garden that is 10 meters long and 5 meters wide. The question is, how much fencing is needed? To visualize this problem, imagine looking down at the garden from above. We have a rectangle where the length is 10 meters and the width is 5 meters. The dimensions are clearly marked. The length is 10 meters and the width is 5 meters. These measurements tell us the size of each side of our rectangular garden. Now, what exactly are we looking for? We need to find the perimeter, the total distance around the outside edge of the garden. This is where the fence will go. To solve this problem, we use the perimeter formula for a rectangle. Remember, perimeter equals 2 times the quantity length plus width. This formula works because a rectangle has two lengths and two widths. Now we substitute our known values into the formula. The length is 10 meters and the width is 5 meters. So we have perimeter equals 2 times the quantity 10 plus 5. First, we solve what's inside the parentheses. 10 plus 5 equals 15. So now we have perimeter equals 2 times 15. Finally, we multiply. 2 times 15 equals 30. Therefore, the perimeter is 30 meters. This means the gardener needs exactly 30 meters of fencing material. Notice how important the units are in our answer. We measured the garden in meters, so our perimeter is also in meters. Always remember to include the correct units in your final answer. This tells us exactly what quantity we're measuring. This problem demonstrates why understanding perimeter is so practical. Whether you're fencing a garden, framing a picture, or calculating the trim needed around a room, you're finding the distance around the outside edge, the perimeter. Now we'll apply our understanding of area to solve a practical problem that many of us face at home: painting a room. Here's our scenario. You want to paint a wall that is 4 meters wide and 3 meters high. The question is, how much paint do you need to cover this wall? First, let's visualize our wall. We have a rectangular wall that measures 4 meters in width and 3 meters in height. These are the two dimensions we need to calculate the area. To find the area of a rectangle, we use the formula area equals length times width. This formula tells us how much surface area we need to cover. Step 1. We identify our dimensions. The length is 4 meters and the width is 3 meters. Notice that for area calculations, it doesn't matter which dimension we call length or width. The result will be the same. Step 2. We substitute our values into the formula. Area equals 4 times 3. Step 3. We calculate the result. 4 times 3 equals 12 square meters. This means our wall has an area of 12 square meters that needs to be painted. Now that we know the area is 12 square meters, we need to understand how this relates to buying paint. Paint is typically sold with coverage information on the label. Most paints cover between 10 to 12 square meters per liter, depending on the surface texture and paint type. To calculate how much paint we need, we divide the area to cover by the coverage per liter. So 12 square meters divided by 10 square meters per liter equals 1.2 liters. Here's a practical tip. Always buy slightly more paint than your calculation suggests. This accounts for touch-ups, multiple coats if needed, and ensures you have matching paint for future repairs. So in summary, we calculated the wall area using length times width, which gave us 12 square meters. Then we used the paint coverage rate to determine we need approximately 1.2 liters of paint. This systematic approach works for any painting project. Understanding area calculations like this one is essential for many real-world applications, from home improvement projects to professional construction work. Now we'll tackle our third problem-solving strategy, focusing on volume calculations. This time we're dealing with container capacity, a practical application you encounter every day. Here's our problem. We have a cylindrical container with a radius of 5 centimeters and a height of 10 centimeters. We need to find out how much liquid this container can hold. Let me show you what this cylinder looks like. Notice it has a circular base and top, with straight sides connecting them. This is the classic shape of many containers like cans, bottles, and tanks. Now let's clearly mark our given dimensions. The radius is 5 centimeters. That's the distance from the center to the edge of the circular base. The height is 10 centimeters, the distance from bottom to top. To find the volume of a cylinder, we use this formula. Volume equals pi times radius squared times height. This formula works because we're essentially finding the area of the circular base and multiplying by the height. Now let's substitute our values step by step. This methodical approach helps avoid errors and makes the solution clear. Step 1. Substitute our values. Radius is 5, so r squared becomes 5 squared. Height is 10, so we have pi times 5 squared times 10. Step 2. Calculate 5 squared. 5 times 5 equals 25. So now we have pi times 25 times 10. Step 3. Multiply 25 times 10, which gives us 250. So we have pi times 250. Step 4. Multiply by pi. 250 times pi equals approximately 785.4 cubic centimeters. This is our final answer for the volume. But let's make this more relatable by converting to units you use every day. Here are the key unit conversions you need to know. 1 cubic centimeter equals 1 milliliter, and 1,000 milliliters equals 1 liter. So our container can hold 785.4 cubic centimeters, which is the same as 785.4 milliliters, or about 0.785 liters. That's roughly the size of a large water bottle. Understanding volume calculations helps you in many real situations, from cooking and baking to determining storage capacity or even calculating how much paint you need for a project. Remember the key steps. Identify the shape, use the correct formula, substitute your values carefully, and convert to practical units. This systematic approach works for any volume problem you encounter. Now we'll explore two powerful advanced techniques that will help you tackle more complex measurement problems: shape decomposition and unit conversion. The first technique is decomposition, breaking complex shapes into simpler, familiar shapes. This is incredibly useful when dealing with irregular or composite shapes that don't fit standard formulas. Here's a practical example. Imagine you need to carpet an L-shaped room. The irregular shape makes it challenging to calculate the area directly, but we can solve this by breaking it into two rectangles. Step 1. Identify the two rectangles. I can see a horizontal rectangle that's 12 feet by 8 feet and a vertical rectangle that's 6 feet by 10 feet. Step 2. Calculate the area of each rectangle using the formula area equals length times width. Now for rectangle 2, 6 times 10 equals 60 square feet. Step 3. Add the areas together to get the total area. 96 plus 60 equals 156 square feet. Now let's explore the second advanced technique, unit conversion. Often, measurements are given in different units than what you need for your final answer. Here's a common scenario. You're measuring a garden's perimeter, but the measurements are in feet, and you need the answer in meters. Step 1. Identify the conversion factor. 1 foot equals 0.3048 meters. This is our key to converting between the two units. Step 2. Convert each dimension from feet to meters. Length, 20 feet times point equals 6.096 meters. Width, 15 feet times 0.3048 equals 4.572 meters. Step 3. Calculate the perimeter using the converted measurements. Perimeter equals 2 times length plus width, which gives us 2 times 6.096 plus 4.572, equaling 21.336 meters. These advanced techniques, decomposition and unit conversion, are essential tools for solving real-world measurement problems. Decomposition helps you handle complex shapes, while unit conversion ensures your calculations use consistent units throughout. Before we wrap up, let's recap the 3 fundamental measurement concepts we've explored today and see how they shape the world around us. First, perimeter measures the distance around the boundary of any two-dimensional shape. Whether you're fencing a garden or framing a picture, you're working with perimeter. Second, area measures the space enclosed within a shape's boundaries. From painting walls to calculating carpet needed for a room, area is everywhere in our daily lives. Third, volume measures the three-dimensional space that an object occupies. Whether you're filling a swimming pool or designing storage containers, volume calculations are essential. These concepts aren't just academic exercises. They're the foundation of countless professional fields and everyday applications. In architecture, these measurements determine everything from the amount of flooring needed to the structural integrity of buildings. Architects use perimeter for foundation planning, area for material estimates, and volume for space utilization. Engineers rely on these concepts for manufacturing precision, calculating fluid capacities in tanks and pipes, and optimizing material usage in everything from car engines to spacecraft. Designers use these measurements for creating packaging that fits products perfectly, planning graphic layouts, and organizing interior spaces for maximum functionality and aesthetic appeal. The beauty of mathematics is that once you understand these fundamental concepts, you can apply them to solve countless real-world problems. If this video helped you understand perimeter, area, and volume, please give it a thumbs up. Your support helps us create more educational content. Have questions about specific problems or want to see more examples? Drop them in the comments below. We read every comment and use your feedback to improve our explanations. Don't forget to subscribe and hit the notification bell to stay updated with our latest math tutorials. We cover everything from basic concepts to advanced problem-solving techniques. Remember, mathematics is all around us. The more you practice applying these concepts, the more natural they become. Now you have the tools to measure the world around you. Whether you're planning a home renovation, designing a garden, or pursuing a career in STEM, these fundamental concepts will serve you well. Keep practicing, stay curious, and remember that every expert was once a beginner. Great job today, and we'll see you in the next video.